Assalamu students, this is lecture number 3 of topic sound of O-level physics. So in this lecture, we will be solving the exercise of this chapter. So section A consists of multiple choice question MCQs. So question number 1 says, which of the following statement best describes how sound travel from one place to another? So in part A, sound wave, the transverse wave, no, it is wrong. It is longitudinal wave, transverse, wrong. B is also wrong. Sound waves are longitudinal wave propagated by the vibration of the particles. So this is correct. Sound waves are longitudinal wave which move outward in circle in increasing rate. It is water waves. So option C is correct. Number 2, a compression in a sound wave refers to a region where the molecules move very close together, a region where the wavefronts are crowded together, molecules of which vibrate. So the molecules are very close together in the compression points. We have studied that, or air pressure is higher in that region. So option A is correct. Number 3, a normal person can hear sounds whose frequency lie between. We have studied at 20 to 20 kilohertz. So option B is correct. Number 4, astronauts in space need to communicate with each other by radio links because sound waves become distorted in space. Sound waves travel very slowly in space. Sound waves cannot travel in space. So option D is correct. We have studied that sound waves need medium. So in space there is no medium to travel through by sound waves. So that is why sound waves cannot travel in space. So that is, and this is the reason why astronauts need or use radio links to communicate each other. Number 5, standing in a long corridor, 10 meters in front of a wall, a boy made a sharp tap on the floor. If the speed of sound in air is 340 meters per second, how long will the echo be heard? So echo is actually a reflected wave. So suppose this is a wall and this is a boy which is standing 10 meters from the wall. So the speed is given and the distance. If wave is produced like this, it will reflect by reflected by the wall. So the total distance covered by the wave is 10 plus 10, 20 meter. So the formula is speed equal to distance over time, or time is equal to distance over speed. So distance is 10 plus 10, 20, and speed is 340. So 20 over 340 gives you the time it will take. It is 0.059 seconds. So option C is correct. Structure questions. Question number 1. Sound is transmitted as longitudinal wave motion and it's set up rarefactions and compression in the medium. Explain briefly the meaning of the words printed in italics. So you have to write first definition and some explanation of rarefactions and compressions. What is the distance between the center of a rarefaction and center of a nearest compression? It is obviously half of wavelength. So you can write here lambda by 2, half of wavelength. One compression and the distance between the one rarefaction and the nearest compression. Number 2, question number 2. Part A, given that the speed of sound in air is 330 meter per second, calculate the frequency of a note which set up a wavelength of 5 centimeter in air. So you have to calculate the wavelength, frequency. So we know that V is equal to F lambda. I'm doing here, part A. V is equal to F lambda or F equal to V over lambda. So V is what? V is 330 and lambda is 0.5 centimeter, which is 0.05 meters. If I convert this centimeter into meters, I have to divide 5 by 100. So I get 0.05 meters. So the wavelength is 0.05 meter. Use your calculator to calculate this value. So we get 6,600 hertz. This is the frequency of the sound note. Part B. Is this frequency within the limit of audibility of human ear? Obviously, because audible range is 20,000 hertz, so this frequency is in the range. So answer is yes. Complete the following table. Speed of sound is 330. The medium is what? Obviously, it is air. In water, it is about 1500, and in steel, it is like about 5000 meter per second. Number 4. Way and may each strikes tuning for. The waveforms on the sound produced are as shown. What can we deduce about the sound coming from the air tuning fork? So if I count the number of waves, one, two, three, four, 5 waves. Similarly, one, two, three, four, and 5 waves. So you can see that the wavelength 5 waves takes this distance, and here 5 waves takes this distance. So the tuning for the frequency is almost same, but the amplitude is different. It means the wave has hit the tuning fork with greater force. So that is why the amplitude becomes higher. Question number 5. Explain how an echo is formed. So echo is formed when the sound wave strike at some hurdle or wall, and it goes back or reflect back. Part B. A man stands from same distance away from the cliff, some distance away from a cliff. He gives a shout and hears his echo 4 seconds later. So this is the time of the time to travel the wave. How far away is he from the cliff? So I'm doing this part here. Suppose this is cliff and this is the man standing. So the distance between the man and the cliff is, suppose this is D. So the reflected wave or the sound wave that starts from man and reflect back at the cliff and goes back towards man has covered the distance of 2D. So the speed is equal to distance over time. So now distance is 2D over time. Okay, I'm solving it. So if I manipulate this, t will multiply by v and 2 will divide the whole expression. So we get d equal to 2t, vt vt over 2. So d will be equal to v is 330 given in the question, and time it took is 4 seconds and divided by 2. So the distance will be 660 meter if I calculate the expression. So this is the distance between the man and the cliff. Now question number 6. In an experiment determine the speed of sound in air, a student hangs 2 blocks of wood together When standing 125-meter away from the high wall, the student hears the echo from the wall within 1 second of banging the block together. When he bangs a block repeatedly at a certain regular time rate, he can no longer hear the echoes. Explain why he cannot hear the echoes when he bangs the block at a particular rate. Because when the echo come and at the same moment he bangs, so the sound wave. So here will be actually the sum of the sound produced by banging and the echo. That is why he cannot hear any kind of echo. पार्ट बी लाइक जैसे वो आया साउंड इको यानी इको आई है वापस, तो उसी वक्त उसने बैंक किया है, तो इसी वजह से जो वेव है वो दोनों की वेव ऐड हो गई है, इस वजह से उसको अलग से फील नहीं हुआ कि इको आई है. Part B, the lowest rate of banging for which the echoes cannot be heard is 81 bangs per minute. Calculated wave speed of sound. So gangs per minute means this is actually a frequency. Calculated value of the speed of sound. So V is equal to F lambda. Or if I so the speed is equal to distance over time. So distance will be 2 times of this 125-meter, because 125 is actually separation of the person and the wall. So distance is 125 multiplied by 2, and the time the wave takes will be like it is 81 bangs per minute. It means 1 minute, one bang, or 81 bangs means 80 waves will produced in sound, different sound waves will produced in 1 minute. So how much time one wave has taken? So it will be like 1 minute, sorry, 80 minutes, 80 bangs, 1 minute or 60 seconds, whereas the distance, one bang will be 60 over 80. So this is the time that one wave takes. So distance is 2d over time. So 2 times distance is 125 and time is 60 over 80. So if you calculate it, 2 multiplied 125 divided by 60 over 80, we get 333. Or in three significant figures, this answer is 333 meter per second. All right, next question. Number 7. A microphone was used to convert various sound waves to electrical oscillations, which were then displayed on the suitable adjusted oscilloscope. Oscilloscope is a device which shows the wave. The four traces below show to the same rate displacement against time. In each of the spaces below, write one, or if necessary, more than one of the letters A, B, C, or D, which sound has have the same pitch as A. Pitch means it should have same frequency. So you can see that D and A has same pitch. So answer is D. The same amplitude as A. So you can see in the diagram, D and B has same amplitude as A. So answer is B and D. The same pitch as B. Same pitch as B is should be frequency like this. Yes, B and C. So answer is C. Because pitch depends on the frequency. So the frequencies are similar or same. So that is why I have chosen B and C are having similar pitch or same pitch. Number 8, the diagram below shows a boat which sends out pulses of ultrasonic high frequency sound waves at intervals of 10 milliseconds. The pulses of wave are reflected from the seabed and echoes are received at the boat. For convenience, the outgoing pulses and the echoes are displayed on a suitably synchronized oscilloscope. The oscilloscope display on the screen shows two pulses of ultrasonic waves and is between an echo from the seabed. A scale close to a screen shows the time delay in milliseconds. This scale is actually in milliseconds. All right. So what is the time taken for a pulse to travel from board to the seabed and back, given that it is uh, mm, less than 10 millisecond? So you can see that this wave starts at 10 and at 7, and the echo heard at 7 millisecond. As you can see, that distance and the time interval is 7 millisecond. So answer is 7 millisecond. Then echo will be heard. Number 2, the speed of sound in water is 1500 meter per second. So calculate the corresponding depth of water below the transmitter. The speed is given and the time is also given. So we can find the depth. The depth is suppose the depth is d. So it means the wave will travel d plus d 2d distance. So v is equal to 2d over t, or d will be equal to vt over 2. Now putting the values, I'm doing this here. D equal to vt. V is 1500 in water, whereas the time it took is 7 milliseconds. So 7 multiplied by 10 is to power minus 3 because it is in milliseconds. Multiply by, divided by 2. So 1500 multiplied by 7 multiplied by 10 is to minus 3 divided by 2. So answer is 5.25 meters. So this is the depth, 5.225 meters. Part 3. How and why will the picture on the screen change as the boat travel into deep water? In deep water, the seabed distance from the boat will be higher, so it means it will take more time for the wave to reflected back to be reflected back. So this picture will be like this reflected pulse will be after the 7 millisecond, or it might be after 8, 10, 11, 12, depends on the depth of the sea. So this spike or this pulse will go towards right hand side of the oscilloscope. All right, so this is exercise solution, and we have discussed all the questions. You must write all of the solution or answers of the questions in your notebook, and then bring your notebooks in school so we can check them. All right, take care. Allah Hafiz.